Hey scholars, today you will learn about the properties and characteristics of minerals. By the end of this lesson, you should be able to know the main two classification of minerals, the properties and characteristics of minerals. Before we begin, let's activate some prior knowledge. What is a mineral? What are the four questions that geologists ask to determine if a mineral is inorganic? What is a mineral? What are the four questions geologists ask to determine if a mineral is inorganic? What is a mineral? A mineral is a natural, inorganic, solid formed in the earth crust. What are the four questions geologists ask to determine if a mineral is inorganic? Geologists ask whether the substance is inorganic. Geologists ask whether the substance occurs naturally in the earth. Geologists determine whether the substance is a solid. Geologists ask whether the substance has a definite chemical composition. It's an element or compound. If the answer is yes for all those questions, then you have a mineral. Most minerals are originated in the earth crust. The earth crust is also known as the lithosphere. The lithosphere is the outermost thin layer of the earth, and hundreds of minerals are found in the earth crust. Minerals have a variety of different colors and characteristics that make up their composition. Minerals are made in the earth crust. They are not made by humans or machines. They occur naturally in the earth and nature. Minerals can be found all around you. They are used in many forms. They are used as a material to make a house, computer, racks, clothes, and many other uses. The earth crust contains more than 2,000 kinds of minerals. Fewer than 20 of them are common. Common minerals are called rock-forming minerals because they form the rocks of the earth crust. Of the 20 rock-forming minerals, 10 are so common that they make up 90% of the mass of the earth crust. Minerals such as feldspar, quartz, olivine, muscovite, biotite, calcite, magnetite, hematite, pyroxene, and amphibole are known as the most 10 common minerals found in the earth crust. Mineral classification. All minerals can be classified into two main groups based on their chemical composition: silicate minerals and non-silicate minerals, are the two main classifications of minerals. Silicate minerals. All silicate minerals contain atoms of the element silicon and the element oxygen. Silicate minerals make 90% of the Earth's crust. Some silicate is composed of only silicon and oxygen, but most silicate minerals also contain one or more other kinds of atoms attached to it, or elements. For example, the mineral quartz, which have one atom of silicon and another atom of oxygen with a subscript of 2, is only composed of silicon and oxygen. The mineral orthoclase feldspar have silicon and oxygen combined with the potassium and aluminum. The mineral orthoclase feldspar results when the metal is potassium. This mineral has potassium and aluminum with 2 silicates, silicon and oxygen. Because the chemical composition of this mineral contains the atom elements silicon and oxygen, you can conclude that this is a silicate mineral. Another example of silicate is quartz. And in contrast to orthoclase feldspar, quartz does not combine with other elements and is still a silicate because it has the elements silicon and oxygen. Non-silicate minerals. Non-silicate minerals are minerals that do not contain silicon in their chemical composition. Non-silicates minerals make 4% of the Earth's crust. A good example of a non-silicate mineral is halite. Halite, as shown in the left image, is the original form of table salt. Halite chemical composition contains one element of sodium and one element of chlorine. And as you can see, it is not a non-silicate because it does not have a silicon and oxygen element. Almost all minerals in the Earth's crust have a crystalline structure. Crystalline materials will sometimes form a crystal. A crystal is a solid substance that has a definite shape, as you can see in the image to the right. Each piece of quartz have their own definite shape in their own definite volume. Now, let's put what we have learned into practice. What is the difference between silicate minerals and non-silicate minerals? Take 1 minute and answer this question. Remember to pause if you need extra time. What is the difference between silicate minerals and non-silicate minerals? Silicate minerals contain atoms or elements of silicon and the element of oxygen, and non-silicate minerals do not contain the elements silicon and oxygen. Characteristics of minerals. Each mineral has specific properties that are a direct result of its own chemical composition. These properties provide useful clues for identifying minerals. You can identify these properties by simply looking, observing, and touching a mineral. Some of the properties that you can identify in minerals are colors, streak, luster, cleavage or fracture, and hardness. Color. A color is a property of minerals that you can easily observe. Some minerals have distinctive colors. For instance, as you can observe in the image to the right, you can see the mineral olivine. Olivine color is green as it appears to the human eyes. If you look down to the bottom, you will find biotite. And biotite appeared to be black. If you look at the image all the way to the top left, you will find calcite. And calcite appeared to be white or dark white. Streak. Streak is the internal color of minerals in powder form. If you were to scratch a mineral against a hard surface, like a porcelain tile, it will leave behind a streak of powder color. These powder color sometimes are different from the original color of the mineral. Some minerals display the same color, while most mineral will always display a different color on its powder form. Luster. A luster is when light is reflected from the surface of a mineral. The luster of minerals can be divided into metallic or non-metallic minerals. Minerals that reflect light, like a polished metal, are said to have a metallic luster. Most metallic minerals resemble the appearance of a flat piece of steel. Most metallic minerals resemble the appearance of a flat piece of steel. They often look like shiny metal. In regard to metallic minerals, as you can see in the image all the way to the left top, you will find the mineral gold. And this mineral, it's said to be metallic. Why? Because it reflects the light. And a non-metallic luster do not reflect light. There are several types of non-metallic luster, such as glassite non-minerals. A good example is shown in the image above, which is the mineral quartz. The mineral quartz shows a glassy feature. You also have a waxy luster, which is a mineral with an appearance as a candle wax. You also have pearly luster. The mineral mica is an example of a pearly luster. You also have shiny luster. Those are minerals that shine like silk. A good example of that is diamond. Cleavage and fracture. Cleavage are minerals that tend to split, fracture, and break easily along certain flat surface. A cleavage is related to the type of bonds in the internal structure of the mineral. Hardness. Hardness is the ability of a mineral to resist scratches. The hardness of mineral can be determined by using the Mohs scale. The Mohs scale is a table that shows the hardness of minerals in a scale of 1 to 10. In a scale of 1 to 10, As you can observe, in the Mohs scale displayed to the left, the softest mineral is talc, which has a hardness of 1, and you can scratch talc with your fingernail, but you cannot scratch diamond with your fingernail. Diamond can in fact scratch your fingernail. Diamond is much harder than corundum, the mineral just before it in the scale, with a hardness of 9. Now, let's put what we have learned into practice. What are the two major classifications of minerals? What are the properties and characteristics of minerals? Take 2 minutes and answer this question. Remember to pause if you need extra time.
Huh?